and welcome to today's SQL Office Hours session. We'll start with a question or a problem that some of you might have encountered at some point. You're in some debate with someone in your organization, and they're not sure who's more senior. So like, well, show me the organization chart, show me where you sit in the hierarchy, and we'll figure out who's more senior, so who gets right of way here. Or maybe you haven't been in this debate, but you've actually had to write the query to do this, to generate out the organization chart. So, for example, we'll have a little simple tree in the organization. Typically, you've got your CEO at the top, and then you've got below him direct reports, the board, so the CXO, CFO, Chief Operating Officer, that kind of thing. They've got their vice presidents or senior vice presidents below them, and eventually you get down to us who actually do the real work, right? So we've got this hierarchy, and maybe you've been tasked with actually doing this in SQL. So you've got to create a query which kind of lays out this structure so we can see who reports to who, where they are, where they sit in the hierarchy, and that kind of thing. Now, one way you could approach this is to do something like this. You could start off, so we're going to pull out from the employees table whoever the CEO is. So that will get us the first person, and then we will join that to the board. So we'll pull out all the rows for the board. And then once we've got those, we need to get the next level down, so the vice presidents, senior vice presidents, whatever they are, join those in, and so on and so forth. So we can keep adding more and more joins to this as we need to go further and further down the organization chart till we actually get to us, the poor souls who actually do the real work, like I say. So we could do this, right? We can do this. Well, yes, but you absolutely should not do this, right? This is absolutely the wrong way to approach it. And there's actually quite a lot of the reasons why you shouldn't do this. First up, you'll notice that we've listed the employees table 3 times here. Now, something I've talked about in the past is if you're using the same table more than once in a query, it's a sign that maybe there's a better way to do it. It's not a hard and fast rule, but particularly in this case where we've got the same table and all the joins are the same, we're just joining employee ID to manager ID, then it's a sign that actually we could probably change our SQL for the better. So that's the kind of first thing. We've got the employees table listed many times. The next important thing here is we've limited our organization chart to 3 levels, right? If there's a 4th level, they're not going to appear in the results. If we want to add those in, we've got to add another join. And you've got to keep adding joins until you know how deep the tree can be, how big the organization chart can get. And they can get, you can get management chains which are quite large, right? 7 or 8 people in the chain all the way up to the top. And you have to include all of those in the results. So that's a pain. Now, something like an org chart, you could probably reasonably figure out the maximum, how far we need to go down. But in the real world, there's a good chance, or other scenarios, I should say, there's a good chance that you just don't know how far down you have to go. And you don't want to chop off the bottom of your hierarchy just because you forgot to add a join in. And there's another kind of bit more of a subtle problem here. For each time we're adding another layer into our hierarchy here, then those people appear as extra columns in the output rather than extra rows, which might not be what you want. So we'll see an example of that in a little bit. So this is absolutely not what you want to do. If you're traversing a hierarchy, so for example, company org chart, you don't want to join everything like this. What you want to use are hierarchical queries. And there are 2 ways to do this in Oracle Database. That is connect by and recursive with. We'll look at both of these in this session and compare and contrast them and kind of decide which we think is better or which we prefer in all the scenarios. All right, so hi everyone, I'm Chris Saxon. I'm part of Gerald Benzel's developer advocate team. It's my job to help you get the best out of Oracle Database and hopefully have some fun whilst doing so. So with that in mind, it's always great to be here with these SQL Office Hour sessions. It's a chance to kind of dive into a SQL topic, answer your questions, explore it, see what we can learn about it. So as I said, this is your chance to kind of get involved, and if there's anything you don't understand, please put in the Q&A. I'll be stopping at regular points to review what's there and answer questions as we go along. So we'll look at how recursive with and connect by work. But actually, before we do that, let's just take a step back and think a bit more. So we looked at making your company's organization chart. And I've chosen that because it's a problem we're all familiar with. I'm pretty sure all of you watching either work for a company or have worked for a company at some point. And so, you're familiar with kind of organization chains. But the chances are, other than like demos and trying things out, you probably haven't had to write a query like that for real, right, in a real application. However, there are a lot of other scenarios where these constructs, connect by, recursive with, can be really useful. So I'll just mention some of these briefly to kind of say that this is a bigger, tools in your toolkit to solve bigger problems than just drawing out your company org chart. So firstly, perhaps most obviously, we can use these to traverse trees, so hierarchy data trees. So for example, we've looked at company org charts. We could also use it to do things like bill of materials. So in manufacturing, they need to figure out what all the components they need are to make a particular good. So for example, you've got your car, and your car has a number of components in it. So a car has got its bodywork, the chassis, it's got wheels, it's got an engine, it's got brakes, and so on and so forth. And then each one of those, again, you can break into smaller components. The wheels are made up of the tires, the hubcap, potentially the spokes, or the alloys, or whatever it is. You've got nuts and bolts holding it all together. Maybe the brakes are part of that too, and so on and so forth. And you can keep going recursively down until you get to the smallest component, something you'll actually buy from a third party or manufacturer from scratch, such as a screw or a nut or that kind of thing. And in order to make a car, you need to know what all the parts are you need, right? We need an engine, which needs this, which needs that, and so on. We can use a hierarchy to actually build that up, see how everything relates, and find out how many we need of each individual thing altogether. Next, of course, there is genealogy, family trees, how we relate to each other, right? Who your parents are, who your children are, who your cousins are, that kind of thing. Now, it's worth noting with these, using SQL to draw out or traverse family trees is actually quite tricky. And there's two key reasons for this. One is to just do with how family trees work in general. So all of us have two biological parents. And data trees, in computer science terms, each node or each entry has at most one parent. So we kind of doubled up the information. This makes following the hierarchy tricky. You might double up on things. So that makes building the queries trickier to start with. The next thing is more of a kind of like a human thing, right? Okay, a lot of families can get a bit messy and complicated once people start getting divorced, remarried, have children with different partners, that kind of thing. Even if you're just drawing out a family tree by hand, it can get really tricky when you've got, if there's several divorces in a family, that kind of thing. So while you can use SQL to do family trees, it's actually a surprisingly hard problem to solve. I'm not going to cover that today. Maybe we can talk about it later if we've got time. The next thing is if you've got recursive calculations. So you've got calculations that depend on each other. So a couple of examples I've got here. So if you've got stock management or stock management applications. So you've got a warehouse, you've got goods in them, and every time you purchase stuff or add stuff to the warehouse, you increase the stock. Every time you sell or use it, consume it, you decrease it. Okay, and we need to kind of keep track of what the running total we've actually got in stock so far, or the predicted total in the future. If we've got predicted orders coming in and going out, about making sure we've got enough stock available. Now, it is worth noting, in the simple case, you can solve this stock problem just using analytic functions, just taking the sum, adding and subtracting as necessary. But of course, in the real world, there can be some hard constraints. It is impossible to have less than 0 of something on a shelf, right? Either it's there or it's not. I can't have -1 of a good on a shelf. Now, From a business perspective, it is of course possible to sell goods you've not got, and you just need to buy it in or manufacture it in time. But if you're looking at actual inventory management and you need to know what's actually there, it can never fall below zero. So you need, checks in there. It says if the total goes below zero, then round it or change it. Similarly, there might be an upper limit on how much you can actually physically store in a location. You say, once you've got past this amount, then we need to send it to an overflow or something like that. And to do that, we need the kind of recursive nature and say, this is what we're at so far. We've got 100 units of whatever. We've sold 200. Well, we can't go down to minus 100. So we need to set that to zero and do something else with 100. So we've got recursive calculations. The other thing is like the product function. So I'm sure you're all familiar with sum, which is just repeated addition. Just add up all the values to get the total. The product is repeated multiplication. So just multiply together all the values. Now there is no product or mul or whatever you want to call it aggregate function in SQL. It's not built in. We can use recursive queries, however, to kind of emulate this and just kind of chain on the multiplications together. Another use case you can get it for is data generation. Very common, you want to do this. Two of the most common I come across is generating dates. So you want to build a report and you want to show every day in February or every day this year, every day last year, something like that. So you just need to generate that data. Side note, I think generally it's much better to actually create a real physical table to store this information for dates, because there's lots of metadata you might want to store, like, is this actually a working day? But quite often, certainly just if you're doing ad hoc queries, you'll just want to generate it on the fly. Similarly, when you're building new applications, new features, new tables, you probably want to create some test data, right? And load that in. So we can use, again, these hierarchical queries to generate data for us on the fly. So I see a comment saying we can also hierarchical like menu. Another good example, actually, we've got various drop downs. So you go to file and then open and it shows you recent files, that kind of thing. So there's lots of examples here. See another one. As well as determining the LLC, low level code of an item in a BOM, also in multiple BOMs, low level, So getting the codes, the product information. So these are just a few examples. I'm sure there's more. Just to kind of point out that these features aren't just necessarily about building your organization chart or following a tree. There are actually lots of other reasons why you might want to or can use these. Okay, so let's move on. So we've got our tree. Before we jump into SQL, just a little bit of terminology to make sure we're kind of all on the same page. So we've got our org chart, our tree here, and each entry here is going to be a row in the table, or in hierarchical terminology, this would be a node. Each of these is a node. And what we need to define is the parent-child relationship here. So we need to know what relates to what. Okay, so in this case, the manager is the parent, their direct report, their subordinate is the child. And this kind of makes sense. It's like kind of like family relationships. You'll notice this terminology mixes and matches between like family ancestry terminology like parent-child and natural terminology, as we'll see in a second. So one of the key things we want to determine here is what is the parent-child relationship? How do we know which value is a parent of another, which is a child? So that is a key thing we need to actually build the hierarchy. Next key thing that we really need to know is what is the starting point? What is the root? As I said, we get some natural terminology. We get some things from nature here. So root, like a tree, trees have roots. Data trees have roots here. Unlike real physical trees out there that are growing in my garden, trees, you say the roots are generally at the bottom. With data trees, the root is considered to be the top. Okay, so subtle thing to be aware of. Make sure you are traversing the tree in the correct direction. Roots are considered the top generally, and then you will go down through the parent-child relationship through the tree. And as we do that, we will have the things at a different level. So we start at the roots, and we'll say that's at level 1. Then all the CEO's direct reports, they're all at level 2. So that they are all at the same level or same depth in the hierarchy. Then everyone who reports those will be at level 3, and there could be further levels as well. There's almost certainly some people who report to these VPs below them. And as we saw with that first query when I was joining, we would stop at level 3. We wouldn't be able to get further than that. With connect by and recursive with, we can go as deep as we want, or as deep as the tree can actually go. Right, so how do we actually do that? Well, let's start with connect by. Connect by, nice and simple. There's just kind of 4 parts to it, really. Just your basic select and from, and then we got our start with and connect by clauses. So start with, this is what defines the root nodes in the tree. And this is probably one of the classic mistakes I see people make when using connect by and they're not sure what to do. They will try and use the where clause to define the root. I'm pretty sure I did this in the past when I first started writing SQL 15 odd years ago. Key thing here is the start with clause, kind of as the name implies, defines what the starting points are. If you miss this out, you will then generate a hierarchy for every single row in the table, and you will get a massive explosion of data and way more information than you are looking for. So make sure you define your starting points, your roots. And a table could have multiple roots in it. Now, org charts, typically there's one CEO at the top, but it's possible to have multiple. Here at Oracle, we did actually have 2 CEOs for a brief period of time. So there could be multiple nodes, but things like bill of materials type things, then actually there could be multiple starting points in the hierarchy. And it's like, are you drawing the tree for every single one of them, or do you just need to pick out an individual component? Are we getting the whole car, or are we just focusing on the engine? Do we just need to get the wheels? That kind of thing. The other thing here is we don't actually have to start at the overall master route. We don't have to start with a CEO. We could draw out the chart for a particular department and just choose like the head of IT and make them the root. So that defines the root for with connect by, and then we have the parent-child relationship. So we have connect by, and notice we have this keyword prior. Now, this is one of the things. There's only 2 ways you can choose it, which side you need to put it on. Somehow it always takes at least 3 goes to get it right? It's just like, how does that work? Okay. Good way to think about it. When you're saying the prior, you're saying the previous row in the hierarchy, the parent row. So what is the value from the parent row that you want to get for this child? So with the manager employee or manager report hierarchy, the child row that has their manager ID points to the parent employee ID. So we've got prior employee ID equals the manager ID. Okay, when it's a bit more not quite so obvious, it usually takes 1 or 2 goes of flipping it around to make sure you got it the right way around to figure this out. So that's the key thing with connect by. Pretty straightforward. There's just 2 things we need there. Let's have a look at recursive with. Now, this is a bit more complicated. We'll put this on the screen and you see like, whoa, there's a lot more going on here. Instead of just those 2 extra clauses, we've got a whole bunch of stuff. So first up, we are using that with clause, and we have unioned 2 queries together. So the one at the top, the first part of that is where we identify the root nodes, the starting points for the tree. Okay, and that will be the same where clause as we had in that start with clause for connect by. We then need to define the parent-child relationship. We do that in the union all, the second part of the union all. And the key thing here is the parent value come from the actual name of the with clause. So whatever we've called this here, I've called it org chart. You can call it whatever you want. Those are the values from the parent row, and you must use this in that union all branch. If you don't, it's not a recursive query. It's just a straightforward with a union all. Okay. So the org chart stores the parent values, and then we have to build the relationship as appropriate. So that's enough of little kind of theory introductions. Let's jump into some demo and see how these work in practice. I'll see one of the comments or a couple of comments. I'll pick those up quickly. how many routes can we define? You can have as many routes as you want. Like you say, there's really no limit on how many routes you have. It's up to you to decide. I mean, we had that org chart. The CEO is the ultimate route starting point, but you could actually do it for each department. You could say, we know who the heads of the departments are, and these are their names or their employee IDs, and they will be the routes, and we'll draw out the trees beneath them. Just say they are the routes. You can, like a where clause, it finds all the rows. That start with clause finds all the rows that you define to be the routes are, and it's up to you to know what that is. You've got to, depends on your business problem, that kind of thing. So as many as you want, right? It can get a bit tricky. You've got multiple routes in one query to see what's what, but there's no limits from database terms, right? Okay, another comment. Would you have to use the with clause for multiple routes? For example, the hierarchical menu with multiple menus you want to show? Nope, you can do that with connect by as well. I'll show you an example in a minute. Okay, both of these, you can have as many routes as you want. It's usually, certainly when you're first building it, start with one route, because it can get very, very confusing if you made a mistake somewhere and you've got lots of subtrees or multiple routes. Good idea to start with one, but once you've got the tree built correctly, there's no limit there. Okay, so someone's saying audio blips. You can all hear me all right still, or is it just one or two of you? Okay, so here's the query that I showed at the start and said was we had problems with. So as we saw, we've got I've actually done it 4 levels deep, and you'll notice we've actually duplicated up the whole hierarchy in all these columns. So I said there was a problem where adding those columns rather than rows. These are the people at the bottom of the tree, and we have to work our way up. So we've duplicated the CEO multiple times. But also, actually, those of you know the employees table well, know actually there's way more rows in the table than the 10 we've got. And that's because we've done this as an inner join. I actually need to do this right, stick it there, make it an outer join. So there are some departments which only go 3 levels deep. So we make that left join, you can see there's all ones missing here. So this is all just a bit messy and tricky to manage. So let's look at doing this with connect by. And I'll kind of do these side by side so we can kind of compare them, connect by and recursive with. I'll start with connect by, basic org chart. We're drawing out, starting with the manager is null, so that's Stephen King, and then we got our chart like that. We can do the same with recursive with. We're finding, if I just run that query on its own, you see find Stephen King, and we've got org chart, so we will recursively generate those out. So we've got our 2 trees here. Okay, right? Well, problem is, it's not very obvious we've actually drawn a tree here, right? This could just be, it's hard to tell that I've actually traversed the tree rather than just running this query on its own. You know, if I just get rid of the start with and connect by, we actually get the same output in terms of what we see on the screen. So it's not obvious that we've actually followed a tree here. So we want to add some extra metadata in there to see what's going on. Actually, before I do that, I'll just show what happens if I do omit the root, so no start with clause. You'll notice, so over on the right here, we've got 107 rows, because we're now generating the tree for every single person. We've actually got 315 rows, right? And you'll see we sort by employee ID. Some people are appearing there multiple times. That's because we got Stephen, Nina reports to Stephen, so in that hierarchy, but then Nina is also then the manager of that department, so they are the root of their own subtree and so on. So we've got way too much information. So we want to make sure we have that start with clause. And as I say, to make this more obvious, let's add some more metadata to see what's actually going on here. So one is I'm going to add in the level, so how deep we are in the tree, and that starts with 1. So we just use level and connect by, and we can see we've got Stephen at the top, Nina reports to him, so they're at level 2. Then we got Nancy reports to Nina, they're at level 3, and then all Nancy's direct reports are at level 4. Okay, so that's pretty straightforward. How do we do this with recursive with? Well, as you'll see with a lot of these things, when it comes to recursive with, we kind of have to roll our own to some degree. So in identifying the root, we'll add a column, call it tree level, and set that to 1 as the starting point. And then in the recursive part, we need to increment it, increase it by 1 each time. So we need to roll our own level query, essentially. Do that, and you can see that we will get this level added to the end. Now, at this point, an interesting little detail we'll come back to a bit more later on. But notice that connect by, we go down. We go 1, 2, 3, 4 down the tree. Whereas with recursive with, we start at 1, and then we visit all of King's direct reports. We go to level 2. We go across the tree. I'll talk about this a bit more detail later on, because we'll see how that works. But first thing to notice here, not only do we have to do how we add the level and so on is a bit more work, but functionally they actually work slightly different out of the box in terms of how you get the data. So adding the depth in there is nice, but again, if we kind of scroll down somewhere in the middle and look at Peter here, okay, they're at depth 3, but what's their management hierarchy? What's their reporting chain? Well, it's not really very obvious here. We've got to kind of reason it back out. Ideally, what we'd like to see is the route we took down to get to Peter in the tree. So we can do that with connect by, with this sysconnect by path. So we'll have a chain of employee IDs, and then the second argument is a separator between them. So we'll just comma separate them. And we'll do that, and now you can see we built up that hierarchy. So if we scroll down to somewhere in the middle here, Joshua. So Joshua's 140, his manager is 123, whoever it is, and their manager is Stephen King at the top, 100. It's one thing to note here is the separator that we've added, scrolling too far there, separator we've added is also prefixed. So you'll notice all of these have a comma at the start. So you probably want to remove that, trim it out of your results to actually exclude that. But this is really useful to see how we got to a particular row in the hierarchy, which path did we actually take. So how do we do that with recursive with? Well, again, we've got to kind of roll our own here. So in the root, we will select the employee ID. Notice I have to 2char it because this is a number, and we're using string concatenation here, and this just avoids type conversion problems. So we're having to the hierarchy, add in, extend on or concatenate on each employee ID each time. And there we go. We can now see what we got. And again, you can now see perhaps even more clearly that we're kind of going across with recursive with, we're going down with connect by, and eventually get to these people here. All right. So that was kind of the basics I was going to cover. I'll see there's a couple of questions. Okay, does the performance get degraded if we have deeper leaves? Depends, it's one of those always, it depends. I mean, the deeper you go down, the more data you're fetching, probably. And the more data you're processing, the longer the query is going to take, right? Get more stuff, it's going to take longer. There's no kind of specific issues around it that at least not that I'm aware of. But, just generally, fetch more data, your query is going to take longer to process. So, but again, depends a lot on specifics. If you've got a problem, give us an example and actually submit it on Ask Tom itself, and we look at that in a bit more detail. All right. When bringing a large set of data, by performing the wrong way, repeating tables multiple times and joining, the result set comes back quicker than using connect by. What would be the reason? Again, it will depend a lot on how this is actually working in terms of how you're accessing data. There's a small chance that somehow the wrong way here is able to use indexes that the right way of connect by isn't. It might be that you're actually getting different data, okay? And that's an important thing to check here is how are you actually mapping these? It's one of those, how there's lots of possible causes. If you have a specific problem, then you should get the execution plan submit it to Ask Tom, and we can look at it in detail, because it's really difficult to answer in the abstract. You know, it's like saying, okay, I want to travel, I want to take my car, drive to work. The fastest route that, according to my GPS system, was actually slowest today. Why? Well, you know, it depends, right? Lots of possible reasons. Give us the details. We can look at it and look at it in more information. Okay, sorry, missed how you move leading commas, connect ways. Yeah, all right, sorry. I just kind of waffled about that and didn't actually show you. So you would do L-trim. So L-trim like this. So this removes trim from the left, that character. So we'll L-trim this, and you remove it off there. So L-trim is the one that you want to use there. So hopefully that answers your question there. All right, and I see I'll cover one more, and then we'll move on. Will you cover some using hierarchy SQL total salaries at level 2? We'll see if we've got time, right? We can come back to that later on. See if we've got. I'll leave that one up. Okay, so that was just some basics of recursive with and connect by, and that was just drawing the tree, adding some metadata so we could actually see the path we took through there. And one of the things we noticed there is actually they return the rows in a different order. So that leads to an important or interesting question. How do we sort the rows? How do we get them to have the same order? Or how do we change the order that they actually return in? So before we jump into the SQL, let's just look at the ways we can actually traverse a tree. So one of them is breadth first. And as I say here, get all the children first. So we'll start with the CEO at the top, and we're going to go across. Then we will access all the children of this row. So this is all the CEO's direct reports. We will get all those rows next, or return all those rows next. Only after getting all the CEO's direct reports do we then go down to the next level. So at this point, we then get all the children of the board, the CXOs. We get all those VPs. So we keep going across. We return all the rows at the same level before going down to the next level. So that is breadth first search. Alternatively, we could do like the connect by does by default and use depth first. So this is where we go down as far as we can to find our nodes. So we'll start with the CEO, we'll access one of their children, CFO, and then we'll come down to the VP. So we'll go down like this. Once we've got to someone who has no direct reports, they're not a manager. VPs are almost certainly managers in the real world. I've only got 3 deep in this, just keep it manageable, right? Having got to the bottom of the tree here, we then kind of go back up to find a row with an unaccessed child. So we'll go back up to the CFO and ask, does this have an unvisited child? The answer is yes. We go to that VP. We're at the bottom of the tree again. So at this point, we'll go back up to the CEO. We'll pick one of their children, one of their direct reports as the next one. So we'll go down to the CEO here, go down to the VP. So with breadth first, we're always going across. With depth first, we're always going down as far as we can and then back up and down as necessary. So that's breadth first and depth first. And, and we can sort the rows in either way with both of these. We'll talk about those in a second. Now, one of the things I've said here is I've talked about finding the leads, or these people at the bottom, the non-managers. So how can we do that? So how can we find the non-managers? So again, brief terminology. Again, we're back to nature rather than family trees. The ones at the bottom are the leaves. So the way you remember it is like trees in the real world grow from the roots upwards. In computer science terms, trees grow from the root at the top down to the leaves. Makes perfect sense, right? Okay. Don't ask me. I didn't make this up, but that's the convention that is followed. So we go down to the leaves, and they are the nodes, the rows that have no children. So that's all those VPs here. One other thing, brief thing here is as well, going back to the family tree, we're mixing and matching our analogies a bit here, talk about siblings. So these are all the rows which have the same parent. So both of these VPs report to the CFO, so they are siblings. The other VPs are not siblings of this because they have a different parents. Okay, so how can we sort the rows like this, or how can we change the sorting? So start with connect by. And as we saw in the demo a minute ago, by default, connect by returns the rows in depth first order. So it travels down the tree and gets the bottom first leaf, then goes back up to the next leaf, so on and so forth. And we haven't actually defined which sequence we pick those children here. And as far as I know, at least, a bit like a select query without an order by, that depth first sequence is probably, may not be defined or not strictly defined. Now, one thing to note here is, and this applies both to connect by and recursive with, if you just stick a plain order by on here without doing some little magic, you will lose the tree structure. So if we order by employee ID or employee name, we will lose that depth first, breadth first ordering. We'll just get them sorted alphabetically or numerically, whatever that is. If you want to preserve this tree structure, we have to do something a little bit special. So with connect by, we've got this siblings clause. So that sorts the children of each row. So this defines which one we access first when going down. So we could sort it by employee ID, we could sort it alphabetically. That will determine which is the first leaf that we actually get to in the tree. So we can use the order siblings to control that hierarchy there. If we want things in breadth first order, so we want to go across, we can order by level first. So order by level, and then whatever other sorting you need. So that will return all the rows at level 1 first, then all the rows at level 2, level 3, so on and so forth. And once we got to the bottom, if we want to find all the leaves, we can just use this handy connect by is leaf function. And that's just return 0 for the non-leaves and 1 if it is a leaf. Now, one other interesting thing here is a little idiosyncrasy of SQL. So we got select from where, start with connect by as the order we've written things here. However, this where clause is processed after start with connect by. Okay, so only after traversing the whole tree do we then process the where clause. And if you think about that, this must be the case to find the leaves. There's no general way to know if a row is in fact a leaf until you've traveled the tree and figured out it is a leaf, right? Because we could travel in different ways and so on and so forth. The where clause is processed after the start with connect by clauses, even though it comes in between them. So that's pretty straightforward with connect by. Let's look at recursive with. And first nice thing about recursive with is it does actually have a specific clause for controlling the sort, right? At the end of the with, we can use this search. You can say search depth or breadth first. So we're going to go down or across by whatever columns. And then I said set sort ID. That adds a column to the output, which says which sequence we got the rows in. So it starts at 1, and then it's just an incrementing counter. So 1, 2, 3, 4, up to however many rows we get in the results. So this is actually, that can be kind of nice, right? You want to know what's the 10th row we visited. Well, we'll have that sort ID. We can get that in the results. So this is kind of nice. But when it comes to finding the leaves, things start to get very, very messy with recursive with, very, very messy. So before we show you how to do this, just a kind of thing to note with depth first search. So we've got depth first search, so we're always going down. When we are at a leaf, the next node we visit will always be at the same depth or higher. So we notice with this VP, and the next node we get in row we get in the output will be its sibling, this VP here. So they're both at level 3. We know CFO is not a leaf because the next one after it, using depth first, going down, will be one of these 2 VPs, and they are at level 3. So this is depth 2, that's depth 3. We're going further down, therefore it is not a leaf. Okay, and we need to use this logic to actually find the leaves using recursive with, right? Okay, so bear with me a minute, right? So first thing we need to do is actually specify its depth first search and add that sorting column. Having done that, we then need to look forward in the results to find the depth of the next row in the output. and say, is that lower or higher? And we can do that with lead. So look forward, get the next row in the results, and say, is it at the same depth or lower? If it is, it's a leaf. Otherwise, it's not. All right. And this is where it's just like, wow, it's a bit of a head, messes with your head a little bit, this one, isn't it? As we can see, a lot of the time with recursive with, you've got to do a lot more work to do things that Connect By kind of gives you for free, right? So yeah, it's a bit fiddly. So at this point, I'm going to jump into another demo, show you how that works. And I'll see another question. I'll see what this is. Do you know of a good resource on SQL statement parsing order that is not excessively long? That's a very good question. Not off the top of my head, right? There's a girl called Julia Evans. You might have seen her on Twitter. She produces what she calls Zines, or e-Zines, I think. She kind of talks about this. She's got one on SQL. That might be a quick place to start. One of the things to bear in mind about SQL is that although there's kind of a logical order and how you process it, that starts to break down very quickly whenever you get to non-trivial queries, because the optimizer can rearrange things in all sorts of crazy and funky ways. So there's a logical order, but the real actual order may then still be even different again because of optimizer transformations. So it's a complex topic, shall we say? Okay, all right. So, all right then. So let's move on. So we'll start off with Connect By again, and I'll just pin that just to show we've got our depth first results. And if I just sort it by employee name, you'll notice now we've got our hierarchy in all sorts of order. Adam Fripp is now the first instead of Stephen King. We haven't started with our root, and you can see we're going all over the place in the hierarchy. They're not following each other. So again, this applies whether you're using Connect By or Recursive with. If you just stick an order by in there, you're probably going to get different results than what you want. Okay, so if we want to control the depth first sorting for Connect By, we have the siblings. So now we will sort the children by employee name. So we go back to before I added it. The first one we visited was Nina here. So Nina reports to Stephen, and then we add Nina's reports. We're now sorting Stephen's direct reports alphabetically. So Adam is first. So that is the first one we get in the output. So we use this order siblings to control that. And notice we still get the actual hierarchy properly here. So that's the one you want to look for here. If we want to do that, actually I'll keep going with Connect By. If we want to go with breadth first, we stick level in here. And now you can see we're getting all of them at the same depth before going down to the next level in the tree. So let's look at recursive with and make it a bit bigger. Now I've added search breadth first, blah, blah, blah. You don't actually need that as we saw before. By default, I'll just remove that a second and look at the plan. Let's make this a little bit bigger. You notice the option here, breadth first. By looking at the plan, that tells us whether we use breadth or depth first. So let's put that back in. We'll actually be explicit here and add the source ID. And now you can see we've got our hierarchy and we know which order we actually access them. I mean, this could be useful for top end queries, that kind of thing. We want to change that to be depth first, sorry. We can put the depth first keyword in there, and now we're going down. So now we've sorted the children alphabetically and we get the same order as we did with if we go back to the siblings here. So these two statements are now equivalent, right? Hopefully anyway, look at them. Yeah, we're getting those in the same order. Okay, so now let's say we want to find the leaves or the roots and the leaves. Now, we can use Connect By isLeaf to get the leaves, and we can use this Connect By root with Connect By to find, to get a value from the root node. So we know at the root, if whatever that returns matches the current employee ID. So that gets us someone at the top. So we've got our CEO, Stephen King, and we find everyone else, their leaves, they've got that value is 1. So that gets all of those. And notice we can put that in the where clause because start with comes first and Connect By. If we want to do something similar with recursive with. It gets a bit hairy. As I said, we have to do our depth first search first, right? Okay, too many firsts in that sentence. And then we need to use our lead here to actually pull them out. And then again, in an outer query, actually return those. And to get the value from the root node, the CEO's name or employee ID, I select it in the root clause, but then I need to keep selecting that root value each time in the recursive path as well. Notice we're getting it from the org chart, from the parent row. That preserves that, and we get that result here. Now, one other little thing to mention here. You notice I've got 3 arguments to lead. Many of you might be familiar with just using one argument like that. I'll just pin this for a second and then run this again. There's a problem here. We do have, at this point, 90 rows in the output. If I remove these second arguments, we've gone down to 89. What's happened there, right? Well, the last node we visit is always going to be a leaf because there's nothing extra. We'll reach the end of our tree. And then lead will return null for that because there is nothing after it, okay? So whenever we compare anything to null, it will disappear from the results. So we need these extra arguments. This says, look 1 row ahead. We can look further ahead if we want. And the one here says, if this is the last, if there is no next row, return the value 1, okay? This is subtly different to putting MVL around here because some of these values could be null potentially. I don't think they could be in this case, but in the general case, they could be null. So important thing to be aware of. So yeah, recursive with a bit more of a faff and pain to deal with in this scenario. Okay, so actually just go back to connect by quickly. As I said, the where clause is processed last. So conceptually, it's like this. We've got our subquery and then process the where clause. Just to help you understand it, you could do a subquery like this with connect by and do the filtering outside it. But these are actually equivalent, these 2 queries. They're exactly the same, but you might find it just to help you understand what's going on. It logically makes more sense. So I say logically, conceptually makes more sense when you're reading the query to do something like this. Okay, couple of questions. What if we need the tree on a table employee where manager change over time? I mean, if I update the manager for someone, then the tree will just re-update. If you need to say, reproduce the hierarchy at a time in a past, you'll need to store that in somehow. You'll need to say, keep a history and say, these are the managers from and to dates, and so on and so forth. That's a bit of a more complex problem. If you want to know more, we can pick it up some other time, right? But basically, as soon as we update somebody's manager, run the query again, we'll get the new hierarchy. If we need to reproduce the hierarchy a year ago, you have to have stored that in some format, all right? Okay. Level is count down from the top. Is there a way to count up from the bottom? You can, there's various ways. One is to kind of, basically you can traverse the whole hierarchy, find out what the maximum depth is, and then subtract the level from that. So basically you need to count down and then subtract back up, or you can travel all the way down and then travel back up. There's various ways. Generally, it gets a bit messy. There isn't really a good way to do it out the box, or at least not that I know of anyway, okay? So sort of yes, but it's a bit fiddly, okay? The example I'm thinking of, we see all subordinates Stephen King at level 2, 3, and 4. I'm not quite sure what you mean when you say that, but basically, if you want to say we've got John Chen who's a leaf and make him level 1 and Stephen King level 4, then what you can do is say what's the maximum depth level, and then subtract the level off that you actually got from that to find that out. Can you do depth first, hierarchy in reverse order, leaf to root? Well, you can start with the leaves, but you need to know what those leaves are. In general, if you want to go from the leaves up, you actually have to have traversed it once down to know who they are. If you know who the leaves are anyway, because you've got a list from somewhere, you're fine. But if you're just kind of in the abstract, where at the bottom, you're just building a tree from scratch, you need to have gone down and then go back up, okay, generally. So you can kind of do these things, but it gets a bit fiddly and messy. Okay, all right, so let's move on. There is one other big important issue to discuss when it comes to traveling hierarchies, and that is loops, right? That's when we've got a, we're going back on ourselves in the tree. So let's take our example here. I think everyone thinks they know better than the CEO, right? Well, maybe we don't, but certainly once you get to VP level, they all think they know better than the CEO, and so they want to tell the CEO what to do here. So this, we've got data error, or this VP's managed to hack the system, and they made themselves the CEO's manager. Great, right? Well, the problem here is now we've got a circle, and we can get potentially stuck in this circle and keep just going around forever and ever and ever. It doesn't matter where we start, we'll always keep going around. So the good news here is if you have a circle like this in your hierarchy, Oracle database will detect this. So you won't, the query won't just run infinitely forever. The bad news is it will stop with an error. So it will just bomb out and go and blow up. So when this happens, it can be really frustrating. You're just like, well, what caused the problem? How do we get to here? What's going on? How do we find what the issue is? So there are ways to do it. Let's look at how we do it with both of these. So connect by. Way to do this with connect by is add the NoSQL keyword. So what this does is if it detects a loop, it will stop, and it stops on the parent row. So it says, it looks at the next row and says, is this the next row I'm going to visit, my child, also a row I've visited in the past? If the answer is yes, then stop, right? And we will not continue traveling any further. So we can add NoSQL in there. So that's pretty simple, pretty straightforward. Recursive with, again, a bit more funky, bit more options going on here. We've got an entire clause dedicated to it, and that is this cycle clause. So with the cycle clause here is, it has to be one of the columns from the with, one of the ones we've defined, but it stops by just looking at this value. So connect by looks at the whole row, essentially. Cycle looks at just this employee ID and says, and unlike connect by, which looks to the next row, recursive with stops on the current row. So it says, if the row we're on, the value for employee ID is also a value we've already seen in the past, change the value of this flag, set is loop to yes to Y instead of no, and stop processing. Okay, so again, subtle difference, not only difference in query, but actually subtle difference in behavior. With recursive with, we get the looped row. With connect by, we don't. So again, let's show you how these both work. So let's go in and let's make someone we'll create a loop here. So we'll put someone to be Stephen King's manager, and we'll run the query. And first thing you notice here, we actually get some results with connect by. And it's only when as we scroll down to eventually we get down to the offending row that we get the problem, okay? So it's possible that you've got a loop in your data, but the query doesn't error because you have not traveled far enough to hit it yet, okay? It's an important thing to be aware of. And again, this is something that does affect recursive with as well. You're just a bit less likely to see it, okay? All right, so we've got our loop. How do we stop it? Well, we'll add in the NoSQL keyword. So now we do that. And we've also got this connect by your cycle keyword function. And so we notice here, we've got Pat. They are the parent of the looped row, okay? So how do we know who do we need to update again? Well, we can put it in a subquery. We can put our thing in there and find a manager for this, and we'll see that, okay, we need to update Stephen King. Well, we know we need to do that because we just did it, but in general, you won't need to. Let's look at this with recursive with. So we've got our loop, and I'll just run it just to show you what happens. Again, boom, recursive with bombs out straight away with our error. To stop it, we will add this cycle clause. So we're going to look for duplicate employee IDs, and we'll change that. Again, you notice that we actually get Stephen King as the looped row. So we see Stephen King twice in the results. We don't see that with connect by, and we set that to yes. And if we want to return just the offending row or the duplicate here, we can just filter it in our where clause like that. Whereas with connect by, we actually need to do something a bit different. Now, one of the interesting things with recursive with, is we can use any of the columns here. So we can create a loop on something that isn't actually a real loop, okay? We're just going to look for duplicate values here. So this time I'm going to loop on department ID, make that our cycle. So what this means is we will stop processing as soon as we see the same department ID again. So I will just go back up. Let's just show what's going on here. So you see, Nina actually has a whole bunch of direct reports, but because we're looping on looping, it's not a real cycle. We've seen Nina and Stephen are in the same department. So this considers it a loop and sets the flag and stops processing. So we do not get the children of Nina. Interesting, okay? This can be useful to spot other kinds of anomalies in your tree. For example, rows that have two parents, okay? It's not possible in this table structure just because the way we store it, but sometimes it might be that a row could have two parents, and then you can end up duplicating rows in your results. We can use this in recursive with to prevent that. Like I say, it doesn't have to be a true all the way round back on yourself. It just has the value duplicated. You can't do that with connect by. Okay. So comment, you think about LPAD, gives a nice visual tree. Yes, nice way of doing it. Okay, so we're pretty close to the hour, so I'm going to wrap up quickly, and then I've got time. I can hang around for some questions if people have some more questions. Okay, so we've got SQL hierarchies. So the important thing is you must define your root nodes. Make sure you identify those either with start with or the root query of recursive with. Without that, you'll duplicate all your rows, and make sure you get your parent-child relationship right. And make sure you get it the right way around. As I say, usually takes a couple of goes. So connect by. Advantage of it, it's nice and simple. We just need to start with connect by, and it has a whole host of built-in functions to do things like find the leaves, return the path, that kind of thing. So it just does more out the box, I think, connect by. Whereas we compare that with recursive with, it's much more wordy. However, big advantage is it's ANSI compliant. So connect by is proprietary, it's specific to Oracle database. Recursive with is like the ISO standard way of doing this. So you can use that on other databases should you need to. I hope you don't, but no. Do what you need to do, right? But the other thing is some of those things like finding the leaves are a bit more fiddly with recursive with. You have to do a bit more typing, and some of them are just a bit of a faff, frankly. That said, recursive with is more powerful, right? It does give you more options. There are things you cannot do with connect by, you can do with recursive with. Okay, so it's worth bearing that in mind. So at this point, I'm curious. I've got a little poll about asking you which you prefer. So if you could just answer that, I've started it. Hopefully you'll see the poll thing somewhere. If you could just click which you prefer, because I'm curious to see which people think, having gone through all that. If you want to know more about these, I don't have the scripts from this particular session available generally, but if you look at this live SQL tutorial, it covers basically the same content, just in a slightly different way. It's a good way of looking at it. And I've got my free SQL course, Databases for Developers Next Level. We look at more of these kind of slightly advanced SQL topics. Fairly clear winner at this point. Right. Okay, so I think most people at this point have voted. So let's just end that and we'll share the results. And we can see that roughly 2/3 of you prefer connect by, only 1/3 of you going for recursive with. It's interesting. If you could share your reasons, or you want to share your reasons in chat or Q&A, I'd love to hear them. Otherwise, really hope you enjoyed this. More importantly, I hope you learned something, and look forward to seeing you in next month's SQL Office Hour session.